Hello, and welcome to Chapter 4, our last chapter of actually describing data. So, we're going to be diving into more fun stuff where we descriptively go through a lot of different graph forms. So, we're going to look at dot plots, stem and leaf displays, percentiles, and box plots. Oh my! Sounds like we're dropping into that rabbit hole. So let's start with, of course, the learning objectives. Yes, we have a grand total of 7. Seems like more than what we usually have. But first, we're going to look at construction and interpreting a dot plot. Identify and compute measures of position. Construct and analyze a box plot. Compute and interpret the coefficient of skewness. Create and interpret a scatter diagram. Woo! We're going to compute and interpret the correlation coefficient. And develop and explain a contingency table. Wow! Lots of stuff in only 28 slides! Ah! And most of those are practice problems. You know y'all love them. So, dot plots. First one is to compare the two data sets like these of the number of vehicles serviced last month for 2 different dealerships. When we look at dot plots, they are useful for comparing, again, 2 different data sets. Now, of course, there are car guys here. This is back using an example from the book in Applewood Auto. So we're going to show the difference in location and dispersion of the observation. To develop a dot plot, we display a dot for each observation along a horizontal number line. If there are identical values, the dots are piled on top of each other. And thus turns into something like this. Alright, now you can use different software. We're going to stay mainly with Excel for the software that we're going to use in this course. But if you take a advanced statistics course, you'll be introduced to Minitab. And Minitab is typically a good statistics software program. If you don't already have Minitab, you can always try it and play around with it. It may actually help you with this course and later on. But we will not be using Minitab. They just like giving examples of other software. But here, it does show how the dot plot is determined. As you can see, we list all the numbers. And again, identical numbers, get an extra dot. It's a good way to actually find mode. You want to look for mode. So, from the 2 dealerships owned by Applewood Auto Group show the difference in location and dispersion of the observations. We can clearly see that the number of vehicles serviced at the Sheffield dealership is more widely dispersed. As you can see, we got some below. There's a wider gap. That's what they're talking about. It has a larger mean than at the Tionista dealership. Okay, so Minitab will calculate the mean for us. We don't have to, but we can use the formulas like we did prior. It also will calculate standard deviation. Yay! Bringing that back. And this is quadrant 1 and quadrant 3. We'll get into those a little bit later. But here, it just gives us a basic visual of how it looks. We can also see where everything is. If there's a bell feature, basically the tallest. Tonista looks like they have a kind of bell feature almost getting done. But it's just basically a plot. That's all it is. That's why it's known as a dot plot. Dot plot. So let's look at our next formula. Yes, the formulas that you have to use in stats. And the next one that comes to you is known as measure of position, which basically measures the locations, also describe the shape of the distribution, and can be expressed as percentiles. So that's what we're dealing with right here, with our little big old P there. So we're going to try and find the location of a percentile. And we'll take our little n, which again is the number plus 1, and our big P divided by 100. So, again, we're going to either look for the first quadrant, second quadrant, we may look at the third, depending on what the data is asking for. So, quartiles divide a set of observation in 4 equal parts. Again, like I was talking about. The interquartile range is the difference between the third quartile. Now I can't say them. And the first quartile. I had them quartiles. Now I can't say them. It happens. Deciles divide a set of observations into 10 equal parts, and percentiles divide a set of operations into 100 equal parts. Okay? Quartiles. I think that's about it. So, of course, we're going to give you an example. Here's our data. We have Morgan Stanley is an investment company with offices located throughout the United States. This is true. We all know about Morgan Stanley. Good investment firm. At least they were for a while, and then mortgage in 2008. Anyway, they listed below the commission earned last month by a sample of 15 brokers. Okay? So the first thing that we need to do when we take any set of data like this is that we're going to have to sort it from smallest to largest. So again, with Excel, we've done that before. I've shown you how to sort. Makes it a lot easier. Next, we're going to find the median. Okay, what number is in the middle? They also use the formula for median, which is L50, because we're looking for the 50th percentile, the 50%, basically halfway. So they take 15 plus 1, which again, that's how many numbers we have, 15 plus 1, so equals to 16, and multiply by 50 divided by 100, which is basically 2. Try to look at this. Yeah. So that's 1/2, so 0.5, which will make it to 8. So, it happens. It happens. I'm like, yeah, 1/2. All right. So the median ends up being 2,038, which is the 8th position. 1, 2, 3, 4, 5, 6, 7, 8. This is why you had to sort from least to greatest. Now, if I want to figure out the 25th percentile or quartile, since this is, but basically, we would look at 25. That's the 4th, which is 1,721. And they're actually looking between the first and third quartiles. So 75 100. So that would be the 12th. Count to the 12th position, respectively. That's 2,205. So, therefore, the first and third quartiles are located on the 4th and 12th positions. So, basically, all we're doing with positions is figuring out which number falls into that position according to the numbers. Will it always be easy? No. But will we try to keep it roughly the same? Yeah, we'll try to. Alright. And again, I go through the practice problems with y'all. So, and if you have any questions, please let me know. It all works out. Now we got the box plot. Yes, I love the box plot. It's a good range kind of thing going on. And you can see why it's called the box plot. So, it's a graph display that shows the general shape of a variable's distribution. It is based on 5 descriptive statistics. First off, it's the maximum and minimum values. The first and third quartiles, and the median. Okay, so this is why we did the measure of positions over here. We found the median, we found the first quartile, and the third quartile. Okay, so the interquartile range is our Q3, or quartile 3, minus quartile 1. Outliers are values that are inconsistent with the rest of the data and are identified with an asterisk and box plots. Okay, so if we do have an outlier, we'll hit an asterisk on that. So when we construct these, we want to begin by drawing a number line that will accommodate the minimum and maximum values. Okay, so they have this different plot graph going on, so it's not exactly like this, but it's using the same format. This plot graph is based on minutes of pizza delivery, which is weird that they jumped from one example to the other. But anyways, just letting you know, giving y'all that inside data, figuring out what PowerPoints end up doing. So, while we construct this, we're going to draw a vertical line above the median, quarter 1 and quartile 3. Enclose the regions between the first and the third quartile, creating the box. Next, draw dotted line segments from the third quartile to the largest value. And again, you do from the first quartile to the smallest value. This shows the largest 25% and the smallest 25% respectively. The interquartile range is the middle 50% of the data. Notice this, it is skewed. Okay? It is skewed more to the minimum. That means we have faster times, and then we have a few numbers that are probably out there. So we know that roughly we do pretty well for a pizza delivery team. So what does this show us the whole way? Which is interesting that they still use. But anyway, so Alexandria Pizza offers free delivery of its pizza within 15 miles. Okay? Kind of like a Jimmy John's thing. How long does a typical delivery take? I want to know that. Within what range will most deliveries be complete? So, they use a sample of 20 deliveries. Again, notice that we're using samples and not the population. We could use population, but that's going to be way too complicated at times for this course. So we're going to typically stay with samples. Okay. So they use the samples of 20 deliveries. Alexander determines the following. Minimum value is 13 minutes. That's the quickest they have done. Their quartile 1 is 15 minutes. Okay. So that was the 25th number, 25th percent number out of the 20. So then we have the median, or it's at half. So 25% is at 5. Half is at 10. This is the 10th number that's in the data at 18 minutes. Then we go to the 75th percentile, our position, which will be about 15 number, which is 22 minutes. Okay. And then the maximum value took them 30 minutes. Okay. Then they want you to develop the box, which is right here, but it's right here too. Again, I think they might have missed the example just slightly on that. All right. So, again, you begin by drawing that number line using the appropriate scale. Next, draw a box that begins at quartile 1, 15 minutes, which falls right between 14 and 16. And quartile 3. Next, we're going to draw the median line at 18 minutes, and then extend the horizontal line and complete our box. So, from here, we have our dotted line to the maximum value, which was 30 minutes, and the minimum value. Again, we know it is positively skewed. Again, the closer to 0 it goes, the more positive skewed it is. The further away from 0, we have a negative skew. So, again, that's just showing us a longer data. And that we also can see a skew with the median as well, because the median is getting pushed more to 0 to make a positive skew and not directly in the middle of our box. Alright, so here's our common shapes of data. La, la, la. Remember the frequency polygons? They're back. So, symmetric, our good fashioned bell curve, where it basically moves, and we can use Euclid's rule on all of this. It's good. Positive skew. Again, the highest peak is more to 0, so it's more positive based. Negative skew is more further away from 0, where the peak lies, and then we have a bimodal, where we have actually 2 peaks, almost symmetrically here. So we have a positive and negative peak going on. Now, usually when we do have a bimodal, shape has, again, the 2 peaks, may indicate 2 or more populations have been combined. So we would have to check on that too. We may have to split it up. But also notice, again, where mean and median are. If mean is on the right side, further away, it becomes positive. If mean is on the inside, or left side, closer to 0, that's also another way to show a negative skewed. Okay? Basically, mean is less than the median, or mean is greater than the median. Alright. Ready for some more formulas? Well, here they are. We're going to talk about how skewness actually happens. So, the coefficient of skewness is measured the symmetry of a distribution. 2 formulas for coefficient of skewness are as follows. We have Professor Carl Pearson developed the simplest formula for calculating skewness, which is based on the difference between the mean and the median. Basically, they have the skewness is 3. Then we have our x bar right there minus the median. So basically our mean divided by our sample size. Now, textbook also shows the software method of skewness, which is a little bit more fun. So, and this is based on the cubed deviations from the mean. So again, there's our data set number, -1, -2, multiply, then we have the sum of our numbers minus the mean, divide by standard deviation, cubed. That's our sample little deviation, sorry. Either way, want to see how this goes? Alright, so the coefficient of skewness can range from -3 to +3. Okay, again, it's going to range from -3 to +3. So if it's more than one of those or less than -3, like -4, because technically it's less, but if we get anything beyond those two, we need to check our calculations. So, a value near -3 indicates considerably negative skewness. A value of 1.63 indicates moderate positive skewness, and a value of 0 means a distribution is symmetrical. Yes, probably going to have a mixture of both of those going on. So example time. Example time. Follow the example and see where it goes. We have the following other earnings per share for a sample of 15 software companies for the year 2018. Their earnings per share are arranged from smallest to largest. Yay, it's already arranged for us. Begin by finding the mean, median, and standard deviation. Find the coefficient of skewness. Alright. What do you conclude about the shape of distribution? Alright, so again, this is formula based. Again, we can use Excel. It's just, I'm going to use Excel when we get into the practice problems, and just rather go through the formula basis when we look at the PowerPoint in itself. But again, we compute the mean, which is the sum of all of our numbers divided by the set. Basically, how many numbers do we have? We find out that the mean is about $4.95. Then we compute the standard deviation. Basically, we take each of our numbers, subtract by our mean. We have to square them, find the sum, and then since this is a sample, it will be n minus 1. Again, watch out for samples. Samples is always n minus 1 when we talk about standard deviation. Okay? So this will figure out standard deviation of $5.22. Then we find the median, the minimum value of the set. So data ranged from the smallest to largest is 3.18. Okay, $3.18. Alright, next we compute the skewness. So here it goes. We're going to take, and look, we're doing the simple formula too, not the cubed one. Alright, so we take 3 times, again, our mean, which was $4.95, minus our median, which was $3.18. then divide by our standard deviation of $5.22, which equals out to $1 and basically 1.017. That's our computation of skewness. It's not $1, sorry. So is it more positive or negative? Well, again, a value of 1.63 indicates moderate positive skewness. This does show closer to 1.63, which we can say there's probably a little bit of positive skew going on because it's as close to 1.63. If it was closer to negative 3, again, we will show a negative response. Negative skewness. Alright. Another fun one. This one I actually enjoyed quite a bit because it's a little bit ways to show how things go. It is known as the scatter diagram, where we plot all of our data. So, it is a graphical technique used to show the relationship between two variables, measured with interval and ratio scales. Remember those from our numeric. So both variables are measured in those level scales. If a scatter of points move from low left to the upper right, it is considered directly positive related. It's moving up. But if the opposite does happen, it goes from the upper left to the lower right, it is negative related. Basically, the slope is going down. So again, we're bringing slope in here. We are going to use slope. Yes. Lots of fun math. I will say that. So, but if the two variables just are scattering, we may not actually have a relationship. So here we go. These are examples of the scatter diagrams. As you can see on the left, we start from the low left, move to the upper right. Notice it's moving up. This is a positive. It's going up. Down here on the right, we can see a slow change as it is decreasing as we go. Here, there's a lot of scatter. It does not seem like there's too much of a shift. We would actually have to figure out the shift here. So, again, we're going to put one of the variables, usually the independent variable, on the horizontal side, and the dependent variable on the vertical side. Okay, again, basically the ones that we can really just change independent, like age. We can pick out age of a vehicle, but the rising maintenance costs as it goes. Maintenance costs is dependent on age. Same here, batting average to home runs. Batting average is more independent, but home runs has to be dependent on the batting average. Days on the market. Usually if we know house prices, the longer the days are on, our independent variable will depend, will have the price depend on that as it goes further out and decreases because people want to sell that house. So, again, we have like no relationship right here between batting average and home runs. They are scattered too much in a straight line. Again, mostly when you look at these, you could try and run a straight line like right through that touches most of them, if you actually see. And you're going to notice that there is some relationship involved. Because not always they're going to be super obvious. So, a statistics called the correlation coefficient can be calculated to measure the direction and strength of the relationship between the two variables. Yes, this is a fun one. I will have to say this. If you have a calculator, statistical calculator, like I think the TI-83 or Casio, you can actually calculate these a little bit easier. But we also have Excel. So we're going to go through as much as we can. I'm going to just basically show you how to use the math to help you out. So here's the formula for correlation coefficient. First off, we're going to have the range. Basically, can range from -1 to +1. Again, closer the coefficient is to -1 or +1, the stronger the relationship. If r is close to 0, we can say that there is no relationship between the variables. So find the relationship. We take the sum of x minus x bar, which is basically our numbers minus our mean for one sub variables, so one variable, and then we do the same with the second set, y minus y bar. Okay, so we're going to find the multiplication of all those. Fun. And then we're going to divide by n minus 1, again, the number of the data points, then times by the standard deviation of x and standard deviation of y. I know, sounds so fun. But of course, we'll show some other love later on, because this one doesn't really have the example. It's okay. So, if it's a perfect negative correlation, line has a negative slope, relationship is equal to -1.0. If it's perfectly positive correlation, it's going to be plus 1.0. These are easier to find out. Again, when we have a bigger scatter and we can barely see a negative or a positive slope going on, we will have to calculate for our correlation of coefficient. Then, now, contingency tables. Okay. A contingency table is used to classify nominal scale observations according to two characteristics. Okay. So again, we have to have identifiable characteristics. Must be at least 2. Okay. Typically, we all usually use 2, but it can be more. We're not going there right now. Okay. It is a cross tabulation that simultaneously summarizes the two variables of interest. Both variables need only to be nominal or ordinal. So, can be ranking or just basically words as they go. So, a contingency table example, because I still don't know why they didn't insert a correlation coefficient one. Works. We probably have a practice problem, so we'll go with it. Applewood Auto Group profit comparison. Okay. So we're looking at our contingency table showing basically the relationship between profit and dealership. They're either going to be above or below median profit. Okay, so again, we want to see how well our cars are going. Right here, we got a total of 90 of the 180 cars sold had a profit above the median and half below. This basically meets the definition of median right there. Basically 90-90. That's fine. Okay, the percentage of profits above the median are Kane with 48%, Olin with 50%. Sheffield with 42%, and Tonista with 60%. Again, this is taking the numbers and basically figuring out percentiles as we go. Okay. Again, taking the number divided by the total. So really all we're doing with a contingency table is basically just putting the table is and analyzing as we go. Wow. Fun stuff. So, I know y'all love listening to my voice. Why not we hit some practice problems? So you know the drill. Once I bring up the question, pause the video, try to work it out yourself, and then let's work it out together. Okay? And hopefully we don't have, like in chapter 3, some question right out of left field that was nothing that we discussed about. Does it happen? I guess so. But let's hope it doesn't happen for 2 chapters in a row. So, of course, considering the following chart, what is this chart called? Should have dot plot. The dot plot. How many observations are in the study? Well, count the dots. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 dots. Anytime you count, you gotta count from Sesame Street. 1, 2, haha. Anyway, what are the maximum and minimum values? Well, the maximum value per this chart is 7, and the minimum value is 1. In fact, we got 2 of the numbers at 1. Okay. Around what values do the observations tend to cluster? Well, that would be pretty much 2 and 3. They are the ones with the most. One has 5, one has 4. So we're clustered right there. Even on this, you can see a more positive skew. I want to keep using those skews. All right. Next, the Thomas Supply Company Incorporated is a distributor of gas-powered generators. As with any business, the length of time customers take to pay their invoices is important. Listed below, arranged from smallest to largest, is the time in days for a sample of the Thomas Supply Company Inc. invoices. Okay, so we're going to have to use some more formulas. Now, the cool thing is, looks like they've already put it in least to greatest. So now, we got to go back and check out our formulas. So here it is, the way that we did. So again, we can find the median, we can find the first and the third quartile. Sorry, going through. Okay. Back to the practice problem. All right. So, for us, we bring out the calculator. There it is. Nice calculator. So first off, we need to figure out how many numbers we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 30 numbers. So we know we have 30 plus 1. That's 1. Now if I want to find the 25th percentile, 25 divided by 100, 0.25 times 31. We're looking at 7.75. So 7.75. We'll go 1, 2, 3, 4, 5, 6, 7. So we have 31, 34. Now, notice that is not exactly 7. So we can't use 7. So we actually have to find basically the 75th number. So they made this one a little bit more fun. So 75th percentile. It's going to be 34 minus so they're going to be 225. So 31 plus 225 equals 33.25. All right. So let me go back through because for some reason it sounds like the mic cut out. But so to determine this when it's a percentage, okay? So it's 7.75. That was our number that we had to find, which number fall there. So we have to take 34, the high number between the two, minus 31, which gives us 3. It's basically our range between the two. And then multiply it by 0.75. Basically, what's after our whole number. This comes out to the 2.25, and then add it to our lowest one in that range, which was 31 between the two. Comes out to 33.25. I'm sure this is going to happen again. So, again, we have 75 divided by 100. That's 0.75. And we're going to multiply by 31. So that's 23.25. So we got to find the 23rd number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Oh, so now we're stuck in the middle again, because again we have a decimal. So 51 minus 50 equals 1. Multiply it by 0.25. 25 plus our lowest. So our quartile is 50.25. Now it asks to find the second decile and 8th decile. So let's do it real quick. Let's see if it gives us a good decile. So deciles are divided, as set by observations, into 10 equal parts. Okay. So we're dealing with 10 equal parts and not 4. So basically we take okay, so for decile, what we need to do is we want to take our 31, which again is our number set, plus 1. And since this is broken out into 10, we're going to do 10. And we find out that it's 3.1. That's where our first tenth of this is located. What we want to find is the second. So we're going to times it by 2, which is a 6.2 position. So 1, 2, 3, 4, 5, 6. So we're at 27 and 31. So again, we should be able to take 31 minus 27. Oops. So 31 minus 27 times by 0.2. That gives us 0.8. So add that to 27. Gives us 27.8. Nice. Where do you go for us? Also wants to find the 8th percentile. So again, taking our 3.1 times 8 will be the 24th.8 number. So again, we would count. We know that's 15. So 16, 17, 18, 19, 20, 21, 22, 23, 24. Now we're at 24 and 20. So we're looking for 24.8, which is in between 53 and 51. So 53 minus 51, that, times by 0.8. We have 1.6. Add it to our lowest. Comes out to 52.6. There's our 8th decile. Nice. Alright, so now they want to determine the 67th percentile. Okay, so P, big P in our formula is 67. So again, we take 67, divide by 100. Oops. Multiply by 31. About number 20.77. I don't think that's actually correct there. Let me check on how that is going. Sorry about that. I had a brain went and did the quartile formula for some reason. So when we look at percentile in itself, that's dividing everything into 100. Okay, so we had decile is 10, and then quartiles use our fancy formula. But here, when we look for the 67th, we're going to take our number, divide by 100, which is 0.31, and then multiply it by 67 for the 67th position, then came out to 2077 still. Yeah, looks like something's a little bit off here. So, again, it's breaking down everything into 100 little spots. So when we look at the 67th position, our book is getting 47, which we just figured out is not the case. So let me give it one more shot of looking at it, see where the book is coming from, and we'll solve it real quick. Okay, so when we work with percentiles, they have a rounding item, which I completely forgot, but that's why we do these videos and do these lectures and practice problems, because even the professor needs to look up some items while he does these live videos. So, since it is 20.22, when we figured out 67, it actually does round down to the 20th percentile or number, basically. So that would end up being 47. So the book is correct on the 47. And just a little rounding. So when we do percentile, when it asks for that specifically, divide everything by 100. and then find your 67th percent, which will be 20. All right, for this one. Radio. It's always fun. It's always fun doing the practice problems. Alright, so the box plot below shows the amount spent for books and supplies per year by students at a 4-year public college. Estimate the median amount spent. Well, I was looking on the graph. Median is that dark black line in the side of the box, and that is right above $800. So, yay, don't have to estimate too hard. Estimate the first and third quartiles for the amount spent. Well, the first one looks about right at 500. It's right in between, while the third is right above 1200. Okay, again, that's the end of the box. Estimate the interquartile range for the amount spent. Well, again, we take the 1200 minus our 500 from the first will give us 700. Okay. Beyond what point is value considered an outlier? So it's going to consider an outlier if it's basically less than 200 or more than 1800, more than our max, more than our least number. Okay. Identify any outliers. We do not see any stars, so there is no outliers. Is the distribution symmetrical or positive or negative skewed? So, which way is it leaning to? Well, it's definitely not symmetrical. It's not right in the middle. So which side has the longer will tell you it's skewed the opposite way. So we see the bigger side on the negative side, which means it's skewed more positive. It's closer to the lower limit. So it's more positive skewed. Ugh. Alright. So, here we go. Some more fun. List below are commissions earned in thousands. Looks like last year by the 15 cell representatives at Furniture Patch Inc. So it looks like we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 numbers. Nice. Okay, so they give us a good median with 15, so we know it's odd. We do have a number right in the middle. So this one we can actually use Excel. So out comes Excel. And we're going to put in our numbers. 3.9. And 15.8, 17.1, 17. And there we go. There's our numbers, all 15 of them. All right. All right. So here's our numbers, and it looks like it's already put in order. Well, let's make sure. Data. Sort. Okay. Yep. No changes whatsoever. Good to go. So I want to insert my line because we're going to have to find standard deviation. So first off, we know right now our median will have to be the 8th number. Because we'll have one, that's not 8th, there it is, because I have the extra line. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. There you go. So I'm right there in the middle. So this is our median right here. I want to highlight that. Oh. There we go. So there's our median is 15.8. Okay. Next, we need to find the mean. So again, you can highlight it all down at the bottom. It will still show you the average. We're going to do it ourselves. So formulas, auto sum. There we go. Then go use our formula, auto sum divided by 15. So notice we got a long percentage. This is actually a repeating one. We're not going to really use that. That's going to be a little bit tough. So we're going to kind of round this off a little bit. So there we go. We'll make it about 21.93. Again, 2 decimal places is okay. Next, we need to find standard deviation, which is going to equal our number minus our mean. So 21.93. Okay, so remember our mean, which would have been X bar, but doesn't give me a really good option to put X bar. It's okay. So our number minus our mean. And boom. And make sure it adds up to 0. Well, it's going to be close to 0, since we're kind of not exactly the mean. But if it's close to 0, we know we're okay. This is what happens when you have lots and lots of decimal places. So yeah, we're right close to 0 if we didn't have the rounding issue. Next, we're going to square. So n minus x bar. And of course, mouse top, square it. So we're going to take each one of these numbers and multiply by 2. Or basically by itself. We're squaring them. There we go. Then again, we find the total. Equal our sum divided by 15. We're looking at 418. That's our variance. And then we have to square root that. Ooh. Yeah. Did I make a mistake? Yeah, I did. 14. We're n minus 1. Forgot a sample. See, it's an easy mistake to make, so make sure you always watch out for it. Again, gotta remember 14. So there's that. That's our variance. It's not our standard deviation yet because we gotta do one last thing. Let's bring in our square root. Square root, where are you? There you are. What gives us to 21.18. Again, if we want to just look at 2 decimal places, go to home and trim decimal places. So 21.8 is our standard deviation. Woo! Fun stuff with the data. Okay. Next, we have to determine the coefficients of skewness using Pearson's method. Okay. So, using Pearson's method, remember it was 3 times. So, we're going to put the formula actually right here. 3 times. So again, whoop. I'll make sure I put the parentheses in this because we got to do the top part first. So it's going to be minus our mean, which was 21.93, which is alright. Let the formula get a little bit out of hand there. Control Z. It's the formula we're working with. So 3 times our mean minus our median okay, so we got 3 times those two, subtract each other, and then we're going to divide it by our standard deviation, which comes out to about 0.868. So that's our coefficient of skewness according to Pearson's method, which again shows a somewhat positive skewness. It's above 0, getting closer to that 1.64. Next, it wants you to go ahead and find out the coefficient of skewness using the software method. All right. So, again, we'll have to look up the formula for that one since we haven't really done. All right. So right here, it looks like we have n divided by n minus 1, n minus 2, and it's going to multiply the sum of our number minus the mean. So the sum of our numbers minus the mean divided by standard. This one's going to be fun. Alright, so let's pop up Excel. Let's get Excel back here. Alright, so we're going to just separate these two as they go. First part, taking our number and divide it by 15 minus 1. Make sure we got 2 decimal places, or 2 parentheses, because we got 2 of bottom formula we have to figure out first. And then we have 15 minus 2. Okay. Close parentheses. Alright, so we have the first part. This is what's going to be multiplying our sum of x minus mean divided by standard deviation. So I'm going to make another column for that kind of formula. So we need to find x minus x bar Can't do X bar. So yeah, this is supposed to be X minus X bar. Alright, so we're going to go ahead and take. This is why the software does it, I guess. Divide it by 21.18. Alright, so there it is. There's all those. And then we have to cube those. Alright, next step equals to this times itself times itself cubed. Alright, now you can see how long this can take. I know there's probably a shortcut, but I need to break it down for y'all too. And it's just fun to do. Alright. So, we have that done. We have it cubed. We now find the sum. Okay. So there's our sum. And now take that. This. Multiply by this. Let's go back to our question. Make sure everything's correct. And that answer is supposed to be 2.44. We're right there because we had a little bit of rounding. So, lots of work right there. So again, this is basically our number. Sorry. It's supposed to be X minus X bar. It should be a little bit better, but again, I can't do X bar. So, X bar. Same thing here. X minus X bar. And then this was X apologize. So this formula was X bar, X minus X bar divided by standard deviation. And then this ends up being that formula. And 2 cubed. So kind of like that. A lot of software statistical data. Again, we can probably figure it out through formulas if we wanted to as we move forward. Because again, there is a bunch of statistical information. Even will have us with percentiles. Here's Pearson. So, but we can figure those out with the formulas in themselves using Excel to help us with the math. Oh, it just takes a little while. This is why we do have statistical data. Alright. This one is create a scatter diagram and compute a correlation coefficient. How would you describe the relationship between these two values? Okay. So we got X, Y, X, Y. Let's see. Then we have Excel. A lot of X's. Let's see. 10, 8, 9, 11, 13, 10, 7, 7, 11. And then Y. 6, 2, 6, 5, 7, 6. 5, 2. Oh, I'm adding pluses. Okay. So take these. Let's see. Graph. Insert. Our scatter. So here's our scatter. Nice little fun little scatter plot that they got going on here. Alright. Y'all saw how I did that? We put our X in one column, Y in our other, which it will naturally put them together. Then you go to Insert, and right here is our scatter. Okay? So this helps us a little bit on looking at our scattered charts. We can even look at different ways. Again, I can even bring out bar if I wanted to. There's bar and risker. But we just want to see it scattered. So right now, judging by that, we have these questions. Well, that's question number 19, so it didn't really give us anything. But how we describe the relationship between the values, it's a positive one, judged by our Excel. So we can actually see it going up. We can definitely see a positive as we further go. Alright. Last practice problem. Last one, and then you're done with the video. Yay! You probably already paused, took a break, and everything. Especially when it goes a little bit long. Alright. So, the director of planning for Divine Dining, Inc. wishes to study the relationship between the time of day a customer dined and whether the guest orders dessert. To investigate the relationship, the manager collected the following information on 200 recent customers. Okay. What is the level of measurement of the two variables? Okay. So both variables are nominal in scale. We don't have really interval or ordinal, ratio to fall into the other types of graphs we've done today. So it is both nominal. We don't have a ranking system either, so it's not ordinal. It's just nominal. What is the above table called? It is a contingency table. Hey. Does the data suggest that customers are more likely to order dessert? So, the answer is yes. Okay. Why does it show it? Well, about 117 out of 200 has done it, which again, if we bust out a calculator, shows about 58% ordered dessert. So yes, it's a little bit skewed. I mean, it shows that more than half have ordered. Does the data suggest that customers at lunchtime are more likely to order dessert? No. Out of the 100, so 68 divided by 100 shows about 68% of customers didn't order dessert. About 32% have. Since it's 100, we really don't have to divide. Just showed you. Customers at dinner time are more likely to order dessert. Yes, about 85% of dinner customers have ordered dessert. Okay? Yay, so much easier to hit these last two than this one. Alright. So, that's it for Chapter 4. Our last data one, description one. We're going to hit into Chapter 5. And enjoy a little bit more as we progress through statistics. Again, this one was a little bit more heavy math-based, more complicated formulas as we go through. This again, why we use software. So, be prepared. I would always suggest have Excel ready to go. It's a good resource for us, and you can always use a graphing calculator. Graphing calculators work as well. If you have any questions, again, let me know. and I will see you next time.